Why don't you just let me know your name and introduce
Great.
yourself?
Patrick Pilarski. I'm an assistant professor in the Department of Medicine here at the University of Alberta, and also an adjunct professor in the Department of Computing Science here at the University of Alberta.
Can you just go a little closer with that?
Yep, sure thing. I'm also a Canada Research Chair in Machine Intelligence for Rehabilitation.
A lot of titles.
Oh, infinite number, too many.
Can you explain what is meant by artificial intelligence and generally how it works?
Sure, what do you think artificial intelligence is?
Well, I think it's something that is non-biological that shows traits of intelligence, such as problem solving, reasoning, and what other avenues of intelligence that you might associate it with it.
Cool. Is artificial the appropriate term?
Oh, that's a good question. You're interviewing me now. Artificial, I think, is the appropriate term for the current state, but once the machines, I'm going to use this term, evolve past what human intelligence is at, then who's to say what's artificial and what's real?
If intelligence is intelligence, can it actually be artificial? Is there such a thing as fake intelligence? Would it really be intelligent?
That's a good question. I think I personally think intelligence is intelligence, and we refer to it, I think the public refers to it as artificial intelligence because they don't want to associate a machine with being equal to them.
Oh, that's a reasonable point. So yeah, artificial intelligence in general, and I think this is a really interesting topic. That's why I bounced back and reverse interviewed you, is because I think there's a lot of misconceptions or even just confusion around the term artificial intelligence and what's meant by it. A lot of things are put under that umbrella. I personally think that the term artificial is actually a flawed use in the phrase artificial intelligence because, again, intelligence is a phenomena. It's been argued, and this is a quote, that it's argued to be one of the most powerful phenomena in the universe. There's degrees or gradations of intelligence, everything from an earthworm or a thermostat right up to humans and dolphins and whales. Intelligence is a very hard to pin down thing, and the very idea of something being a fake or an artificial intelligence is not actually, I think it's really missing the point. So when I usually talk about this, I don't talk about artificial intelligence, despite the fact that I do work in what everyone considers to be the field of artificial intelligence and machine learning, but more so I think of the specific technology that I work on, that we work on here in the lab, and that many of our colleagues work on as machine intelligence. So can we actually begin to have machines that exhibit different degrees of intelligence? Now, this isn't to say superhuman intelligence, although that's one thing that can be meant by this. But really, I think machine intelligence can be brought together in the ideas that a machine might be able to represent its world. It might be able to sort of structure all that information that's in the world into a way that it might do something useful. It might be able to know things about that world, to understand the world in terms of facts, or in our work at least, about predictions of the future, something that, humans have tried to do since we have crawled out of caves and we're rolling the knuckle bones of sheep, is that we want to know what's going to happen tomorrow, next week, next month, next year, or 10 years down the road. So one thing we might think about machine intelligence doing is really predicting the future, or building up facts in the form of predictions about what might happen next. And a final thing that we can think really about intelligence is that it might involve taking actions or making decisions, using that way of structuring the world, using those facts or those predictions about the future to make good decisions, in fact, in the pursuit of a goal. And so when I think about machine intelligence, and really when I think about intelligence in general, it pulls these things together, the idea of structuring or representing the information in the world, of building up facts about that information or forecasts of the future, and then using those things to make good decisions while you're trying to achieve a goal or some set of goals. So that's really what I think I mean by machine intelligence and artificial intelligence. I think it's actually what many other people mean as well. They say it in different ways, and there's many different definitions, but I think in general they mostly come down to those key points. And it also demystifies. Intelligence is a special thing. It's an exciting thing. It's something that drives us and drives many of the other systems in the world around us, biological or otherwise. We should celebrate that and think of it as something that's mysterious and wonderful. At the same time, we can think about it as something that is broken down into a series of well-defined components, something that we can think about and reason about, and then try to implement in our technologies to enhance our own abilities as people, to enhance our quality of life, and to, in general, interact better with the world around us. So I think that's what might be a well placed way of thinking about artificial intelligence and what I would say machine intelligence in general.
Yeah, I like that. So you think the terming artificial intelligence is a bit of a misnomer. Intelligence is intelligence, and to draw this line in the sand doesn't really make sense.
No, I think you're right there. It doesn't make sense, and it is something that may not be really helpful to us moving forward as a society and understanding the potential benefits or pitfalls of intelligent systems technology in general. It potentially sets us up for a lot more mystification, sets us up for misunderstanding what may or may not be possible through machines that exhibit intelligence. And through that misunderstanding can come things like fear, can come overreaction, or can come underreaction to other potential consequences. So I think it's actually really important that we say what we mean and that we think about exactly what we mean without casting on terms that cause more confusion or more uncertainty about the discussions we're having and the policies we're making and the strategic decisions that we as a civilization, as a society, are making about the technologies we create. Poorly defined terms or misplaced terms really don't help that dialogue at all. In fact, they set us back.
Right, and it can even lead to polarizing the debate when you use these terms that are nebulous and vague.
Absolutely. Usually when people hear artificial intelligence, they aren't thinking about their thermostat or their robot vacuum cleaner. They're thinking about a machine that might take their jobs, that might be smarter than they are, that might someday be running the world. Who knows what's going to happen? But a lot of these misunderstandings, I think, really cause people to react to something like a robot vacuum cleaner or a smart thermostat in the way that they might to a superintelligence that they think might someday be ruling the world. Those two things get conflated because of poor terminology, and I don't think that really helps us move forward or make good reasoned decisions.
No, I agree completely. So as a subset of machine intelligence, or the way machine intelligence works, a big area is often machine learning. Could you explain how machines learn?
Yeah, one really simple way to think about it is statistics. Let's use a very, very simple example. Let's have my office. We're sitting in my office right now, and there's another office next door. If every time you come into my office, I were to give you a cookie, every time you go to the office next door, maybe you get 5 cookies. I mean, you could sort of keep a tally, right? You'd have a little crib sheet maybe, or maybe you just keep in your head like, oh, hey, every time I've walked into Patrick's office, I got a cookie. So I've collected maybe 10 cookies going to Patrick's office over the year, and maybe I got like 50 or 60 by going to the neighbor's office over the course of the year. It's a simple statistic. Machines can learn in a very, very similar way. Imagine that you have a machine making a decision and seeing the outcome. It can keep track of what that outcome was, or what that observation or what that information flowing into it was in a given situation, or when it takes a given action, can build up statistics and sometimes summarize those statistics, sometimes build up ways of acting, we call them policies, based on those statistics. So in a very simple sense, and this is, I think, one of the simplest ways to think about it, it's really just an act of bean counting or the little tick, tick, tick with a cross that you can see when you count things. Obviously, there's a lot of very complex mathematics. There's a lot of very advanced methods in machine learning that start to build up fields like machine intelligence and pattern recognition and all these other different fields that we see that relate to intelligent systems in general. But and the idea of a learning machine, really, it's actually well defined in the words. This is a very nice form of terminology where we start to see, a machine can actually learn about its experiences, about the data around it, about the way that it interacts with the world. And the simplest form of that, again, is statistics.
Right. So machine learning is actually very similar to human learning. It learns from its past experiences, sees the outcomes, remembers the outcomes probably better than a human would itself, and then can act on that for the future.
Absolutely. And a really great example, actually, that hits on your point is that reinforcement learning, the field of machine intelligence that I work in, our computational reinforcement learning algorithms are now viewed by neuroscientists as the dominant model for how reinforcement learning occurs in the human brain. So the way that the machines we work on conduct trial and error learning is a very now considered to be by leaders in the field to be a very close approximation of how human trial and error learning works, and it involves things like our dopamine system and some of the deeper structures in our brain and how they project into the rest of our brain. But yeah, the kinds of machine intelligence we study here and the kinds of machine intelligence we're actually world leaders here at the University of Alberta, reinforcement learning and related fields, are now very widely considered to be a good model of how certain systems in the human brain work, especially with respect to reward and trial and error learning.
That's a perfect segue to my next question, is how machine intelligence can help us in the field of medicine.
Excellent. So I think the best example, and this is the example that I spend my career working on, my career at least as it relates to intelligent systems within the field of physical medicine and rehabilitation, is that intelligence allows a system to adapt, to change the way it interacts with the world. In rehabilitation medicine in particular, or in assistive technologies, one of the greatest barriers we have now is that the medical technologies essentially come out with factory defaults, or they're tuned very aggressively in the clinic to work for an individual, but they don't continue to adapt over time. As a person changes, as their technology changes, as their hopes and dreams in daily life and their goals, as these things change over time, their technology doesn't change. It remains static. The person has to work to adapt themselves to the technology, but the technology, for the most part, and this is not a blanket statement, but for the most part, does not adapt to the people that using it. So if someone is attached to an artificial limb or an exoskeleton or any other form of assistive technology, often they are learning about the machine. The machine is not learning about them, adapting to them, and personalizing to their needs. So one really important, I think incredibly powerful impact of machine intelligence on rehabilitation and the entire field of assistive technology is to allow that technology to begin to customize itself, personalize and optimize for individuals, individual needs and individual functions. So technology can learn as well. It can work with people to get better over time, to do the things that people need the technology to do.
So right now, medicine seems to be a one-way street in that it's built around the average person, the 50th percentile, and we're seeing a sort of a revolution where machines can help personalize care for each individual.
To some degree. So I would want to separate out the idea that there's some physical components to technology as well, and those are either personalized or not personalized. I'm not going to speak to that because my colleagues are much better placed to speak on the physical technologies. But in terms of the software, the electronics, the parts of technology that are involved in control, transferring human will and human intent into the actions of the machine, often there is some degree of personalization. So someone with amputation using an artificial limb might be able to dial up their limb on their smartphone and pick different grips for the system that they could select between. In certain cases, there's been the commercialization of a technology called COAPT, which is a pattern recognition system. It's a machine learning system that's been deployed in prosthetics, FDA approved, and it allows the person to some degree train their prosthetic limb to interpret the signals from their body to perform different grips or motions. So there are some examples of the systems personalizing, but widespread, long-term, ongoing adaptation of a system with very little effort is something that is still a missing gap. I think it's one of the biggest gaps we can begin to fill, to make two systems one system, to make a person and their technology the same thing, and to feel like it's the same thing. That's a huge goal.
Yeah, and that might seem a little weird for some people to want to connect those things, but if we look around today, what do you see? Everyone has their phone in their pocket or their hand. And to move past this slightly separated connection to a more direct connection almost seems natural at this point.
Absolutely. We use technology for many things. Technology doesn't just impact medicine. It impacts everyone, almost everyone on the planet, with some limited exceptions. Again, I won't make sweeping statements, but technology is permeating the lives of people everywhere. We use technology to support our sensory abilities, to be able to perceive the world. Heck, I use glasses. We use technology to extend our reach in the world. Everything from those little grippers you use to pick up things that you dropped on the floor, to vehicles that allow us to move it at much faster than we could walk, to the computers that let us actually change things, to transfer funds between bank accounts. We use technology to change how we interact with the world. And we actually use technology regularly to think about the world or process the world. Heck, if I don't have my calendar invites, I would have remembered to meet you today, and maybe this is a downside, that we do put some of our cognition into technology as well. But we are becoming a civilization, a society that does integrate very well with technology. And in the medical sense, we're seeing, I think to some degree, the medical field with respect to rehabilitation in particular is maybe catching up to the widespread consumer electronics industry in how patients will relate to their technology. But even in medicine, technology is revolutionizing the way that we perform medicine, deliver medical care, and that people actually live their lives, specifically people using assistive technologies like artificial limbs.
Yeah, specifically with the artificial limbs, you're a big part of the BLINC lab. Could you tell me what that stands for and what they do?
Yeah, Bionic Limbs for Improved Natural Control Laboratory. This is a lab that was founded by Dr. Jacqueline Hebert, my close collaborator and clinical colleague. I work closely with Jackie and a number of other PIs, students, staff from all different disciplines to come together to allow people to better interact with their assistive technologies, in particular artificial limbs. Upper limbs is our major focus in the group, and we're working very, very hard to improve how people interact with devices in terms of the feedback they receive. So allowing people to feel an artificial limb as if it was their biological limb, to use feedback to better interact with the world, to touch the world, to feel the world, and to carry out their daily life functions. So allow people to feel the limb as if it was their own limb. This is a major focus of our group. Increase the accessibility of the technologies, how people will be able to quickly uptake a new artificial limb technology, and looking at new control technologies as well. This is where I really fit into the picture, is finding new ways for the control systems, the systems that link the human and the machine to communicate human intent to the machine and what the machine feels back to the human. So the BLINC lab is really about allowing people to better interact with their artificial limbs such that they can use them as if they were the biological limbs that they have lost. Make them truly natural and intuitive.
Yeah, so it's almost as if it's their own limb that they're using.
That's the hope. This is one of the grand goals. I mean, I have all sorts of wild dreams of my own that Jackie reins me in all the time. But I mean, you could imagine that an artificial limb may someday be better than the biological limb that was lost. We're not there yet. I mean, we do have side projects in the BLINC lab on a go-go gadget wrist, a telescoping forearm that could extend out. That's something I could never do with my biological limb, but someone who's lost a limb may be able to have an ability that I don't. So we do look at trying to restore function flawlessly. This is a grand goal, but there are the cases where someday certain functions, maybe not every function, but certain things that have been lost might be restored in a way that was better than they originally were. This is another grand goal. It's something that's very ambitious. It's something that requires a lot of thought, but it's something we're seeing in many different fields. Someone who's lost a leg using a cheetah recurve leg to be able to sprint faster than most of the other people on the planet. That's an example of augmentation, of someone gaining something. So a disability becomes a super ability. Many people have spoken on this, people like Hugh Herr and Amy Mullins, and it's an excellent point, but it's something I think we need to think very hard on.
I agree, we need to think very hard on it. How do you see the ethical ramifications of someone, not even a disabled person or someone, an amputee, but a regular person who's been born with all of their limbs and they choose to have one replaced with an upgraded bionic limb?
I'd refer anyone wanting to discuss the ethics of that to a very great book by Max Berry called Machine Man. If they want to at least see the downsides of that particular set of outcomes, it's a fantastic fictional novel, rather dark, very dark and interesting at the same time. I think there's a lot of complexity, and so I just want to highlight the complexity of this, is that there's certain technologies that do involve something like, a full replacement of a limb, whether or not it was a limb that was healthy or damaged. There's augmentation of limbs that are temporary. So adding a limb onto the body. We have a third arm project where we have a wearable third arm that comes out of the back. One of our students has been working on this for a number of years now. That's something you could put on or remove. Something a factory worker could use to be more effective. They could hold, one example from down at MIT is there's two supernumerary limbs that hold large aircraft assembly manifolds. And the person can then use their biological limbs to bolt in these pieces of sheet metal, while the robot arms hold all the really heavy metal. So that's an example I think that we could agree would actually increase the ability of people to do things. There's very few perhaps social downsides you can imagine that particular case study. And what's nice about it as well is that you could imagine, in fact, reducing the number of negative health outcomes down the road. People aren't craning their back and torquing their back. There's assistive robots that are used in factories now in Japan, where it's a small style exoskeleton which will provide lower back support when people are lifting and bending. So there's cases where there's very natural augmentation that does do something that wasn't perhaps possible with the biological system that someone was born with, but that actually improves their ability to function, their ability to contribute to society, and their ability to prevent injury or illness down the road. Another example is exoskeletons that can be used for caregivers in a hospital. These exoskeletons are essentially robots that are attached to the outside of the body. They aren't permanently Someone can put them on like they'd put on a suit of clothing, but slightly different. and that increases that person's ability to lift heavy objects, to continue to lift things over a long period of time, to lift a patient out of bed and move them to another bed, something that actually causes injury for healthcare providers. So that's a system that augments a healthy person's ability to make them able to do something they couldn't do before. And again, we could argue that a technology like that is actually something that we do see as beneficial as a society. And of course, there's examples you can imagine within, say, the military-industrial complex and others where we might see this as something that is negative. Maybe people see that as a positive thing in the interest of national security. It's a gray area. So like every movie, you see something like an Iron Man suit, and then you see the supervillain using a very similar suit. Inherently, the technology itself is simply it's a tool. It's a tool that we need to use very skillfully and for the correct ends, and that is on us. The technology just increases our choices, and of course, when we're faced with choices as a civilization, we often don't think as carefully as we should.
That's a good point. Yeah, it seems to me that whenever we have greater technology, of course, there's the possibility of greater exploitation. Computers revolutionized the world with the internet, but it also gave rise to hackers and people who want to use it for malevolent reasons. But to me, it seems like we would never say we should scrap the internet now that we're here, right? It's turned out to be a pretty positive outcome. I think most people would agree. Maybe not.
Maybe I get a whole sea of email in my inbox that if I didn't have the internet, I could sit at home and actually read all those academic books and journals that I'd love to catch up on. So maybe if there was no email, maybe that actually would make my life better. But let's leave that aside. I think you're right that it's very much like when we look at the foundations of ethics, of medical ethics. Do we believe that the things that we are undertaking are going to have a net positive benefit, or that the possible risks that are involved are going to be small compared to the possible benefits to the people that are interacting with it, or that are participating in that activity? So I think it is grounded in the way that we currently consider ethics, and we do have to think is the potential gain. Not we can never say what the actual outcome is going to be, but are the potential gains fairly significant with respect to the potential harm, the potential causes of negative outcomes? And so that's a trade-off that we look at every day here in the lab. That's a trade-off that all of our students are encouraged to think about. That's a trade-off that I think all of our colleagues here at the University of Alberta think about on a daily basis. It's something that is very foremost in our minds, and very appropriately, all of the companies in the world that are really pursuing, or at least most of the major companies that are pursuing intelligent systems or augmentative technologies, do all actually have a strong commitment to making sure that there is social dialogue, that the ethical concerns are thought about, and that safety is a first and foremost priority, especially when developing intelligent systems technology. There's large consortiums that have been built up now specifically regarding what they call AI safety. So it's something that everyone takes very, very seriously in my field and all the fields that relate to it. So I think it's a nice sign, I think.
Yeah, I was going to ask, that is what you see, is that a lot of people are putting safety as a top pinnacle? Because what I am concerned with is that a big goal for a lot of scientists is to be the first person to discover something that will change the world. And sometimes I worry that this race to be the first person to achieve that will sometimes leave safety in the dust, as we've seen with other technologies. And this technology in particular is so pervasive that it scares me, to be honest, a bit, that there'll be at least one person who doesn't consider safety first and goes forward. How do we prevent that?
If I knew the answer to that particular question, I think a lot of other people would know the answer to that question. I think you wouldn't be answering the question. It's tricky. You can't control the actions of any individual, especially in technologies like the ones we're speaking of. You can't guarantee what anyone will or will not do. What we have to consider, though, is that the resources required to make significant gains might be also fairly significant. So it may not just be coming up with exactly the right equation to be able to understand how to deploy or implement something that might become a very, as you say, a pervasive technology. It requires collaboration, it requires resources, it requires, in fact, checks and balances. And so we see a lot of, for instance, OpenAI. Maybe you're familiar with OpenAI. They have an incredibly large thrust in AI safety, along with their other interleaved thrusts. companies like Google as well have safety as one of their top priorities when they're dealing with intelligent systems. At least that's the public perception. Again, I speak of these large coalitions that have formed to think seriously about AI safety. So because of the collaboration and the requirements for resources, I actually do think you'll see that there are some checks and balances with respect to development, and that the chance of a wild card or an outlier is probably less than we might expect. So that's good. Again, I'm filled with optimism. I actually think this is that things are heading in the right direction, and things will be used for the most positive outcomes possible. I hope we can all see that outcome.
I agree. I'm optimistic as well, but I'd like to flesh out these ideas nonetheless. So even if every human working on this is focused on safety and really excited and pushing it in the right direction, the concept of general AI, maybe I'll ask you, what is general AI?
This is, again, another thing that you ask different people, you'll get different answers. Usually when we talk about artificial general intelligence, or ambitious and artificial intelligence is sometimes what we term it, we talk about a form of intelligence that isn't just optimized to a very specific task. So if you look at certain deployments of machine learning, if you think about, I don't know what kind of phone you have, but if you have any kind of phone with voice recognition, it already has some kind of very advanced pattern analysis system that it links up to. There are certain very specific deployments of intelligent systems technology that are already significantly better than humans at doing their job. Heck, an Excel spreadsheet is a lot better at calculating things than I am on most days. In fact, all days, I think. So we already see that there's certain very specialized forms of machine intelligence, machine computational technology that do one thing, a small collection of things incredibly well. General intelligence could be said to be a system that does more than one task. Now, a very weak way of saying that would be, okay, well, can it do two tasks? Sure. Maybe that's general. Maybe it's general enough. Maybe if you're thinking about some kind of factory automation system, maybe you could give it 10 or 15 different kinds of products to create, and it'll manufacture those equally. A more broader sweeping statement would be that something that say, oh yeah, it'll type your email for you. It'll translate from Latin into Old English. It will translate from Latin into Old English and then do some computation based on that. It will perhaps take your dog for a walk, make you breakfast, figure out the financial balances of several large companies or countries. A system that could do all of those things, or some collection of those things. Maybe not even these big ambitious things, but something that you could let go in the world and it'd be able to function like a human might function. Be able to interpret the world, be able to take on new challenges, be able to deal with the uncertainty inherent in the real world. That's what some people mean by general intelligence. So it's something that, again, condensing it down, is more than just something optimized to solve one specific task using intelligent systems and technology. It's something that can deal with more tasks, more variability in the world. Simple example might be games. You could imagine the arcade learning environment, actually developed by Mike Bowling and his team here on campus. It's an Atari game platform. So you could think of a general intelligence system in the context of just this arcade learning environment is not a system that's really good at playing the games like Pitfall or any of the other different games that you might have, but that you could essentially let loose within this arcade environment, and it could learn to play any of the games in that particular collection, 50 or 100 different Atari games. Even more general intelligence, you could let it loose on your computer. It could download StarCraft, or it could download Minecraft, all sorts of different possible games that you might imagine it downloading and using. Maybe it could even not do any of those things, but maybe it could go on that same computer and order your groceries from your local grocery store. Well, that sounds a lot more general. Well, maybe if it could then go out into the yard, grab your car, and drive itself to the store to pick up those groceries. Oh, wait, wow, okay, that sounds a lot more general. Now, maybe it could design something. Maybe it does painting. Maybe it makes works of art. Well, that sounds even way more general. Now it's doing something really creative, or it's curious about the world, or it undergoes like scientific investigation, tries to understand its world even more fully, like we do. Oh, well, that sounds even way more general. So you can see how this isn't really it's again, not a binary definition. It's not a single definition, but it's a move towards systems that can function in worlds of increasing complexity and generality. Does that answer your question?
Absolutely. It's a continuum.
Absolutely. Much like intelligence.
Exactly. So is it true that some of the most fruitful machine intelligence frameworks are ones that are able to alter their own source code and change themselves?
I'm not sure. So there was I remember self-modifying code was a big thing back in the day. It's like, oh, it's changing its own code. Um, I'm not sure whether it's necessarily the act of changing its own code or, like we talked about earlier, of building up good statistics. So being able to have a continual changing, adapting understanding of the world. I'm not sure which you could say is more powerful or if you can even tease those things apart. Like it may not be that a system is altering its own code. It might be altering its own memory. It might be changing the way that it wires together different modules. Whether or not that's actually changing its programming or that's changing its structure or whether that's the act of learning. It's hard to say. It really depends on what you wish to define. So all of those things said, a system that can actually change its internal structure, can understand its internal structure. This is maybe even getting towards a theory of mind or a theory of self. If the system can actually interpret itself and change its internal structure and be able to do so in the pursuit of a goal, then yeah, I would argue that is more powerful than a system that perhaps has been engineered for a single purpose and let loose without the ability to change its structure or to even perceive its own structure. So I think that we do see more powerful technologies when a system can interpret itself, interpret its own change, and then actually affect change in its own structure, what it's learned, how it learns, and how it structures the information in the world.
Very cool. I want to come back to that theory of self in a bit, but what I'm building towards with these previous two questions is that I foresee a scenario where we have a general machine intelligence that is able to go on the computer and use programming languages and able to make a new machine intelligence. And so it's very foreseeable that if that first intelligence is very smart, it could make an even smarter intelligence. And then that intelligence could in turn do the same thing and make it even more smart intelligence. And we can see the loop that this could go into and what some people have called a intelligence explosion, rather.
A singularity, really.
A singularity is what other people call it. I know that word is used a lot. But what do you think about this?
I think that I have a baby, and I hope that someday my baby is smarter than I am. I think it's natural to think that the things that we help to usher into the world might someday be smarter than we are, and we should actually, as good parents do, treat those systems with respect and do our best to nurture any system that we bring into the world. And we hope that will pass on to the next generation. I think core values, good values will propagate no matter what kind of intelligent system that you're talking about. So I do think that respect and understanding are important. If we build something smarter than we are, I think we should respect it. If it builds something smarter than it is, I hope that it also respects it and tries to set that other system up for even better things than it set up itself up for. So I think really this is it could be a very virtuous or fruitful cycle. I guess one question is, you have an intelligent system. Do you think it should have rights?
Are you asking me?
Yeah.
I mean, intelligence is one thing, but consciousness is another. And I think if the machine is aware that it's alive and it is sentient and can feel, then I do believe they deserve rights. But if intelligence on its own, I don't think inherits rights, because the machine could be very intelligent and it could actually think the best intelligent, rational decision is to shut itself down and allow another machine to do the job better. So I don't think in that case, just having intelligence isn't the basis for rights. I think consciousness would be the basis for rights. I might be digging myself in a hole here, but I'd have to think about that some more. What do you think?
I think I'm not going to, every 10 years or so, I come back to the idea of consciousness and try to think about it hard and realize I'm not smart enough to think about it properly, and I put it back on the shelf for 10 years. So I'm going to leave that one alone completely. I think the ideas of consciousness are as poorly defined as many other things. In fact, maybe more poorly defined, and that's something that requires a lot of thought, and it may or may not actually play into what we mean by systems that act or work like we do.
Sure. Yeah. No. Absolutely. Consciousness is a nebulous topic. But coming back, you were mentioning that we're gonna hopefully nurture things that are smarter than us and propagate our values. But if we take the case study of evolution and our own planet, we see that humans are the most intelligent, at least we like to think we're the most intelligent species on the planet, and we evolved from apes and chimpanzees, and now we see that we perform experiments on chimpanzees. So who's to say, so based on our history, how can we ensure that our seemingly evolution to machinery is going to be benevolent? rather than malevolent.
I think one thing that everyone forgets, and this is maybe an interesting point, is that it's actually really unlikely that the first thing that is smarter than we are is going to be something other than us. We talked earlier about the fact that we use smartphones. I can remember my day timer because my phone's remembering it for me. We often, I think, inappropriately think that superintelligence will just suddenly go pop. Hey, I'm here. How's it going? I'm way smarter than you are. Okay, now I'm gonna like enact some scenario from one of those movies that you all made that you probably don't like. This is, I think, more or less a long-term kind of popping action, and it would probably be even more gradual than that. I think in terms of something that's smarter than we are, it will be some kind of hybrid between a human and a machine. And this really then becomes the question of, well, do we believe that humans will be good to other humans? It'll just be different kinds of humans. Now, I think there's a lot of good case studies on the planet right now that shows that humans aren't being really good to other humans. But again, I remain optimistic that as we become more intelligent, as we become more caring and compassionate, and hopefully technology will help us become more caring and compassionate, that we will actually be able to take better care of each other. And as we integrate more technology into our lives, I have to hope that our capacity for care and compassion increases as well. So when we get smarter, we do a better job of removing the constraints on resources, the constraints on the things that we need to sustain our own life. Because of that, we can be more altruistic. We can work better with the people around us. So by becoming more intelligent, by working hard, either with our meatware, with our existing brains, or with some combination of our existing biological hardware and the technology around us, by working together with technology, we do become smarter. So superintelligence probably won't just go pop and appear out of some server somewhere. It will probably be a gradual improvement of our own capacity for respect and care, because we are augmenting our abilities, our ability to perceive the world, our ability to understand the world, and our ability to take actions in the world. Our ability to some degree, maybe control is the wrong word, but our ability to help manage all the chaos around us will increase as we integrate better technologies into our lives. I think that will make us better neighbors to each other.
Yeah, I agree, but this positive outcome relies on our merging with the machine intelligence. So do you think that's the only way for the outcome to be positive?
I think it's already happening. I think it already happened. So I think that's probably a door that's already been opened and everyone's already walked through it. It's just going to keep moving forward. So unless we're all prepared to leave our smartphones behind, leave behind our Twitter and our Snapchats, and go back to sending paper mail, I think we've already started down that road. I think that's already happening. So I wouldn't worry about it. I actually think I think it's a very positive outcome. I think we're likely to see a positive outcome.
Yeah, I agree. I'm playing devil's advocate though.
Good.
Lost my train of thought.
Okay, and I actually have to run across campus for 3 o'clock. So so if you have some follow-up questions, I realize we've been going for about 40 minutes now.
Yeah, you're
so
right.
it's good conversation, but I do have to run across campus for a photo shoot very soon. So if you have some other follow-up questions that you want to throw in now before I'm waiting for the range pass as well, so you probably bought yourself a couple of extra questions. But do you have more questions? This is great. I love these kind of questions. It's
Me too. This is my biggest area of thinking lately.
Good.
And it just never ceases.
I will give.
My mind.
I give you one without a quote. Is that people? I often have media interviews. I have quite a few media interviews where like, oh, but what about the Terminator scenarios? This is all going to turn out badly. I'm like, if you don't want robots dropping bombs, you don't put bombs on robots. And so it's actually true. But a lot of the major players, like almost all of the major players, researchers in intelligent systems, have all signed open letters never to weaponize our technologies. So this is something I think everyone's agreeing on as well. Is that, yeah, you know what? We don't want machines to cause harm. Let's not work actively to create machines that cause harm. And that's again, it's the intent behind the people working on it. It's the intent is us being good neighbors to other people. We just have to be better neighbors to the guy next door and the gal across the street and the people that live across the ocean that maybe look a little different for us. As long as we're being good to each other, things are moving in the right direction, and technology will just accelerate or amplify that direction that we're already moving.
That's exactly what I was going to say. I think technology amplifies our togetherness and dissolves the us versus them mentality. We've gone from city-states to provinces to countries, and it's only foreseeable that we'll continue to merge, especially as we become more interconnected, as we've seen with the internet and as we move forward.
Yeah. And individual differences might actually increase. So the difference between you and I and you and someone else, it might it might decrease because of technology, or because of people's ability to customize and personalize their environment to themselves. Maybe people will become even more different, and so you'll know that everybody's going to be different. You can't expect some kind of fictitious homogeneity in society, because everyone will use their technology different, and they will understand and interpret the world through their technology in a different way. Maybe we'll have even greater differences of opinion, of lifestyle, of culture because of technology, or perhaps the other outcome is that it connects us even more, and we converge towards other shared values. Either way, I think it increases our diversity and our acceptance of diversity. So I think these are the positive aspects of technology. Not to downplay the possible negative aspects as well, but I think these are the things that we should celebrate, and we should hold in our mind's eye, is that there are some very, very positive outcomes of the forms of technology we've been talking about.
Yeah, it's interesting. I've never thought as much about the enhancement of individualism through this. I've always kind of thought that as we merge with technology, we'll work towards a more collective consciousness. Have you ever thought about that?
It's one very interesting and one dominant model. There's many semi-dominant models of what happens when you have a lot of people all connected together. Is it like, do they all become one person? Do they have become lots of different people? Does it even matter? Are those definitions important definitions? Are the fact that we're trying to make those definitions, is that actually impeding our ability to think clearly about how things are changing? But the answer is we don't know which one of these outcomes or all of these outcomes. Maybe everything. Maybe people are both together and apart. They're two things in one thing, and that doesn't have to be mutually exclusive. Technology makes that to some degree not mutually exclusive, and that's perhaps something that we don't think about as much as we should.
I think we'll leave it there. Thank you, Patrick.
Hey, thanks so much.